Okay guys, welcome to day 2 of the Advent of Code. Hopefully you've already started and seen my first video, so I'm not going to introduce you to it again. Let's get straight into the problem. So you're at this nuclear power plant and they want you to analyze some data for them. So they've given you some sample data here and they're introducing the terminology that they're going to use to describe the data here. So they're saying that the unusual data, your input, consists of many reports, one report per line. So this is a report. So is the second line. Each one of these lines is a report. Each report consists of a list of numbers called levels separated by spaces. So in this case 7 is a level, 6 is a level, 3 is a level, 9 is a level. Cool. So they've given you some example data and they want you to figure out which reports are safe. So the criteria for a safe report is that the levels are all increasing or all decreasing. And also that any two adjacent levels differ by at least 1 and at most 3. Let's take a look in our sample data set. Let's try and find some unsafe reports. So this would be a safe report because they differ by at most 3. Wait, no, this would be an unsafe report because here we have a difference of 5, which is more than 3. So that report's now unsafe. Let's try and find another example. Yeah, look, this is unsafe because that's not differing by at least 1. And then I think that's safe as well. Yeah, cool. All right, I want to get straight into the code. So let's head over there. Alright, so I wrote it in Rust again, and I wanted to use I reused my parsing function, but I changed it a bit. So I wanted to work with an array of arrays, or a 2-dimensional array. In Rust we call those vectors. So I just open the file like before, get it into a vector and return that vector or an error. Nothing too new there. And now the way I implemented part 1 is mostly contained within this function called isSafe. So what we do here is, this is kind of redundant, but that's just for other shapes of data if we were to get some. So we use this code here to check if the report, so that's one row of the data, is all increasing. So we do levels.windows, and what the windows function does is it allows us, as you can see here, when given an array or a slice as it's called in Rust, we can iterate through it, and we can choose how many we want to get. So in this case, we're working in pairs because they care about adjacent values. So we get these windows, and then we go through the windows, and what the all function does is it says that this function, this anonymous function inside, must evaluate to true, or this whole expression is going to evaluate to false. So even if this function evaluates to true for 9 out of the 10 items in the dataset, and then we get false on the last one, this whole variable will become false because of that. And what we're just checking here is that the second element in the array is greater than the first element in the array, and vice versa for decreasing. Now there can be a condition in the dataset where it's not all increasing and it's not all decreasing. So let's say we had the data 1, 3, 2, 4, 5. Well, that's not okay because it goes up and then down. We can't have that. So we handle that by returning false. This function is called for every report. And this function returns a boolean saying whether the report is safe. So that can be true or false. We're using the same Windows API and the same all API here. But with a different function. So here we're just checking if the difference, the absolute difference, recall we used absolute function last time, between the second and the first is less than or equal to 3, okay. And then the isSafe report is for the purposes of part 1 of the challenge, is just a wrapper that calls this function. You don't need to worry about the rest until we start discussing part 2. So just like we saw here, we get the file, get our data in a vector, import it, handle the error. Then we create this variable called sum, which is where we just iterate through the data. and then we filter it. So we filter our data by calling the isSafeReport function. Please don't worry about that until part 2. By calling the isSafeReport function. So after calling this function on our data iterator, we now have an array of safe reports. And then what we do here is we just count the safe reports, and then we print it out to the console so that you can see it. And let's take a look back to the browser and see what our answer was. Our answer was 472. That was the correct answer. Cool. Now let's head straight into part 2. Now, part 1 was okay, but part 2 was pretty confusing for me. So basically, you had to read it, you had to process it, read it out loud if that helps. The engineers are surprised by the low number of safe reports, blah blah blah, and they forget to tell you about the problem dampener. I need to get one of these. That's a nice little Easter egg. Now, the problem dampener allows you to tolerate a single bad level in a report. So it's basically like removing anomalies from your data like you do in practicals in science. We've got an example here for the sake of time. In fact, let's go through it. So as you can see here, this data set would be safe if we just removed 3. So if we had 1, 2, 4, 5, that's fine, that's safe. But because we have this up and then this decrease, that means it's unsafe. But because it's only happening, because if we removed one value, that would now be safe, we just say that the report's safe, thanks to the problem dampener. And they just want you to implement the problem dampener. So let's head back to the IDE and let's check that. Okay. So we rely still on the isSafe just to say that if it's safe, we're just going to ignore it. We're not going to care about the problem dampener because if the report's safe, we don't need to run this code. So we take this as an argument. We say if with problem dampener, then we're gonna run this logic. So we iterate through the levels.length, and we create a new mutable variable called modified report. So that's an array of 32-bit integers, a vector of 32-bit integers, and we just call levels.toVec. So levels is our input of this function. And now this function is called for every level of the report. So that's why we don't need to iterate through the whole report, because that's already done in the main function. So now we've got our modified report, which right now is just the report. So what we do is for each value in the report, we remove it. So we remove the 0th value, which is our first value, then the second, then the third. And we check, after removing that value, is our report now safe? And if our report is now safe, then we return true. And if that's not the case, then we just return false. Okay, and then as you can see, we run that code in pretty much basically the same way. Let's explain it again. Dampen sum. We iterate through our data. We filter our data for reports that are safe, but we use the problem dampener. So we may have unsafe reports, but by removing one value, they're now safe. And then we just count them up and we run them to the console. So let's run this so you can see if it all works. Beautiful. 472 and 520. Okay. How are we doing for time? Alright. About 9 minutes, that's good. I will be hoping to see you all tomorrow, where we'll probably implement the first day. No, not tomorrow, on Wednesday. We'll implement the first day, or Wednesdays, which is the 4th, in Java, and we'll be doing this in IT2. If you're on the robotics team, then if you're on the programming team of the robotics team, then I do expect you to be there. Thank you. Have a good evening.